Hello, everyone. Very pleasant morning to everyone who is present for the session. I deem it as a great pleasure to meet you all through this virtual platform during this prevailing pandemic conditions. I thank the NGM group for having given us this great opportunity to get connected through the session. And as you all know, the title of this entire workshop is Research Prospects and Promises of Deep Learning in Problem Solving. So I wonder why I chose this title. And there are two reasons. One is, as a faculty of computer science, it is our obligatory aspect to know about deep learning, number one. Then number two, deep learning provides a lot of opportunities for research. So I thought it is ideal to learn about what are the research prospects and what are the promises of deep learning for a computer science faculty member. In addition, this deep learning, or as you take artificial intelligence on the whole, has got a lot of prospects for interdisciplinary research. So at any point of time, we can get tagged with the friends of other discipline, wherein we can do some substantial research with added value of societal component or social welfare and many other things instead of focusing on theoretical research as such. So, as a researcher, it is the moral responsibility of any researcher to work on problems related to social issues or any other problem which has to be addressed by the latest technology. So, in these two aspects, with respect to these two perspectives, I feel this workshop is going to serve its purpose in the best possible way. So now let us get into the business. So now, as you all know, we have planned this workshop into 3 sessions, 1 session a day. So today in the first session, we will be covering the aspects related to neural network. So I have put it in 5 different segments. Introduction to neural network, then nuances of neural network, then what are the challenges of neural network, and what do you understand by convolutional neural network, what are the basics of convolutional neural network one should understand to start working with convolutional neural network. And then we will be concluding the session by discussing about a few popular convolutional networks. So I feel it is ideal to start with the definition of artificial intelligence because, deep learning is a subset of artificial intelligence. So the definition goes like this. There are hundreds of definitions about artificial intelligence. Definitions given by dictionaries, definition given by the experts, definition given by the scientists, definition given by the practitioners. There are different perspectives about artificial intelligence as it is being defined. So let us take a very simple definition about artificial intelligence. So it is the art and science, of course, engineering of things that can think, perceive, and act as human beings, and even better. So we have to take a note of this word even better. It is not just to match with the essential qualities of a human being. Instead, it is the objective to make the artificial intelligence and utilize artificial intelligence so that machines can be made to think beyond the intelligence of human being. So artificial intelligence is a discipline, we understand. So we can call it as an art, science, and engineering of making things that can think, perceive, and act as human beings, and even better. So I may request you to reserve your queries or your doubts about why it is even better for a while. Later, as we continue in our discussion, you will be able to understand why we use this terminology even better. Well, so as we trace the birth and development of artificial intelligence, we cannot avoid this personality who is John McCarthy, and he is called as the father of artificial intelligence. So John McCarthy is the one who coined the word artificial intelligence when he wanted to host a workshop to explore the possibilities of developing artificial intelligence based machines and algorithms. So this happened in the year 1956 when he decided for organizing a Dartmouth workshop. So you can Google on this workshop and you can find interesting stories about the birth of artificial intelligence. So John McCarthy was one of the founders of the discipline of artificial intelligence. So there may be a question. We call him as the father of artificial intelligence because he coined the terminology artificial intelligence. Then why do we call him as one of the founders? So at this point of time, we have to understand artificial intelligence is not a standalone discipline. It is not a child of computer science or it is not a branch of computer science. And we have to understand artificial intelligence is a combination of, is, uh, is a consolidation of good amount of theories, principles, practices that we have borrowed from different disciplines. To name a few: cognitive science, biology, physiology, psychology, sociology, mathematics, and of course, computer science. So we try to bring in as many theories as possible from all these disciplines together, and then this artificial intelligence is being made possible. So John McCarthy coined this term artificial intelligence, and he is the one who developed the programming language Lisp, which stands for list processing. So in early 90s, this Lisp ALGOL were the programming languages with which the expert systems were developed. So he had great impact in designing the ALGOL as well, which stands for algorithmic language. So he was consistently at coming out with some success in artificial intelligence. So we can altogether call this great scientist, John McCarthy, as a very influential personality in the early development of artificial intelligence. So here in this slide, you can see a spectrum of scientists who were invited for this Dartmouth conference, which was held in the year 1956. So all these scientists are not computer scientists. They are drawn from different disciplines, as I told you, from mathematics, from philosophy, from psychology, from sociology, from cognitive science, biology, then from optimization theory, and many such things. So these are the images of those noteworthy scientists who were invited for this Dartmouth conference, which year marked the birth of artificial intelligence. So by looking into the slide, we can try to trace the timeline and the development of artificial intelligence over the decades from its inception or from the day in which it was conceived theoretically. So it starts from the year 1950, though I made a mention, the terminology artificial intelligence was coined in the year 1956. 1950 is also an important year in the timeline of artificial intelligence because this is the year in which Alan Turing he experimented on the Turing machine that gave good amount of foundation for the development of artificial intelligence. So though it would be like because the items are so cluttered here, I will take you to the next slide where we can have the glimpses of each of these milestones. So here 1950, 1955, 1961, 1964, 66, Then AI winter. This is the period during which not much development was happening around uh, the world in the light of artificial intelligence. So again, there was a pickup in the year 1997, then 1998, 99, then 2002, 2011, then 2014, 2016, 2018. It progresses. Well, so I'll take you to the next slide, which will make you understand what are the significant events that took place in all these years, which are shown here. So as I told you, in the year 1950, Turing test was conducted. I think being the computer science fraternity, all of us must have heard about Alan Turing, the great scientist. So the computer scientist Alan Turing proposes a test for machine intelligence. So he wanted to have a kind of inference if a machine can trick human into thinking it it as a human or not, and then whether it can have intelligence or not. So he wanted to test what is the feasibility of bringing in artificial intelligence in the machines. So in the year 1955, the term, I mean, artificial intelligence was coined in the proposal which was submitted for the Dartmouth workshop, summer workshop. So in 1955, AI was born. The term artificial intelligence is coined by the computer scientist John McCarthy to describe artificial intelligence as the science and engineering of making intelligent machines. So this is the aspect. That is, it is the art of making intelligent machines. So then in 1961, there was another breakthrough in the name of Unimate. The first industrial robo was introduced, right? So it was able to do some work in the automation, especially in GM, General Motors. Uh, in the automation, it was used. Automated manufacturing, it was used. Then in the year 1964, it was ELIZA. It was a pioneering chatbot which was developed for the first time by MIT that could hold conversation with the human beings. Then, following that, in the year 1966, a Shaky was introduced. This was a general purpose mobile robo which can reasonably be rational about all its action. So, it was able to reason out all its own actions. Then, this is one of the interesting breakthroughs in the history of artificial intelligence. In the year 1997, IBM Deep Blue was introduced. This Deep Blue was the supercomputer which was designed by IBM, which could play chess. And this IBM Deep Blue was made to pick up game with then world chess champion Gary Kasparov. So the surprise of the entire world, Deep Blue was able to win over Gary Kasparov. And of course, he too had a turn, but the number of wins against Gary Kasparov for Deep Blue was more than that of Gary Kasparov's. So in the year 1998, Kismet was introduced. Like this was a kind of emotionally intelligent robo, right? That was first of its kind and which was able to respond to people's feelings. It was able to recognize the feelings of the people around and it was able to respond. Then, in the year 1999, IBO was introduced. IBO stands for AI Robo, and Sony launches the first consumer robo pet dog, right? So, which was able to show some skills and then personality attitude, which was supposed to be there in the artificial intelligence driven robo. In the year 2002, it was the turn for Roomba. Roomba was a small robot which was designed to attend to housecore activities of cleaning. So it was a robotic vacuum cleaner which was able to clean the house. Then in the year 2011, Siri was introduced. All of us are familiar with the Siri. So all iPhone users must be enjoying the services of Siri. So it is an intelligent virtual assistant, which is a voice-enabled virtual assistant used in the iPhone from the 4S onwards. Then in the year 2011, Watson was introduced by IBM. This was a kind of machine which can take questions and then give the answers. So again, this was able to surprise the world by winning $1 million prize in a television quiz show called Jeopardy. So it was able to win over in a quiz. against the human beings. Then in the year 2014, it was the turn for Eugene, and this was called as Gooseman, a chatbot that passed the Turing test to check whether it possesses artificial intelligence or not. And it was it was given to understand that Eugene was able to behave like a human being. So probably these were the foundations for the birth of Sophia that we are familiar with. So all these innovations were put together in the development of Sophia. So then Alexa, we know, then in the year 2016, Tay was introduced. Tay was a Microsoft's chatbot. Tay was able to like it was able to take goes rogue on social media, making inflammatory and offensive racist comments. So, those who are interested to know the details of all these innovations, I would suggest you to just Google and then find what are the specific aspects, features of all these kind of innovations. Another one in the year 2017 was AlphaGo, and this was designed to play the game Go. It was also able to beat the world champion. So this all these innovations are being listed just to make us understand, to have a clear idea that this artificial intelligence was able to bring in a lot of transformational changes, a lot of paradigm shift in the aspects of programming as well as in the aspects of problem solving. In addition to that, this artificial intelligence gave a lot of opportunities for the scientists to think beyond problem solving, something like manufacturing a robo for cleaning the house, and then developing a machine for playing chess. And these are not the aspects of programming for problem solving, it is beyond that. So and the introduction of artificial intelligence, we can say, has brought in a lot of paradigm shift, as well as it was a kind of a transformation and u-turn in the aspect of programming and problem solving. So let us get into the further aspects of artificial intelligence. So then, how was the artificial intelligence able to grow out of its shell? So this artificial intelligence, as we discussed, was able to evolve into another aspect called machine learning, and which in turn grew out as deep learning. So now, at this point of time, I feel I must be able to make a distinct difference between what is meant by artificial intelligence, how does it differ from machine learning and deep learning. So, as we talk about artificial intelligence, as we all understand, it is the ability of machines to simulate human behavior and take decisions intelligently like a human. So, this is the underlying principle. So, we want the machines to mimic the ability of a human being in terms of thinking, decision making, being adaptive, being human in all possible actions. Well, so this defines the boundaries of artificial intelligence. I mean, the ability of machines to simulate human behavior and take decisions intelligently like human beings. So then the next one is machine learning. It is the ability of machines to automatically learn without being explicitly programmed. So here we have to understand the first one, we try to develop a model and we give the boundaries of operation. Within the boundary, the software or the expert system or artificial intelligence driven software or a machine will be able to do certain amount of tasks. But once we put our step into machine learning, there is an added advantage. We develop a software which is intended uh, to solve a particular problem, but this algorithm, by means of the experience it gains during the process of problem solving, or by means of the task that it handles during problem solving, is able to accumulate more amount of knowledge about the process of problem solving, and hence it will be able to solve a problem, understand a problem without being explicitly programmed, right? So this is the keyword, like it will be able to solve the problem without being explicitly programmed. This is second one. Then the third one is deep learning. What is meant by deep learning? This deep learning is a subset of machine learning. This is a special case of machine learning. So it creates an artificial neural network which is capable of learning and taking decisions intelligently with the help of models, artificial intelligence models, or with the help of the deep learning models or machine learning models, as we call them. So there is going to be an algorithm that we call as a model. So the algorithm is going to be tuned properly to suit the requirements of problem solving, and accordingly that model will be able to handle the problem and give us the feasible and optimal solutions. So the AI journey in terms of the years. So we can say there was a kickstart for artificial intelligence in the year 1950. In 1950s, there were a lot of excitements about artificial intelligence, the early development of artificial intelligence. So between 1950s and 1980s, there were a lot of excitements about the early development of AI. So early AI is just excitement. Then from the year 1980s onwards, it was going up to 2010. This was the period where machine learning started flourishing, and there were a lot of innovations, developments were taking place about machine learning. Then later in the year 2010 onwards, from the year 2010 onwards, we can call this as an era of deep learning, and deep learning breakthroughs drive the principle of artificial intelligence or art of artificial intelligence in problem solving. So now let us continue our discussion with neural networks, because to understand deep learning, we have to understand what is meant by neural network. So I do believe most of you must be having basic understanding about neural network, because though this is a good old topic, now we get to listen to this neural network from different domains, from different platforms, that doesn't leave us without understanding what is meant by this neural network, at least with respect to its basics. Well, so we can call this artificial neural network or neural network or networks or the machine learning computational algorithms which are being modeled after the functionalities of human brain. So because it is going to mimic the functionalities of human brain, we call this as artificial neural network, whereas the natural neural network is our biological neural network related to our human brain. So this is designed after the structure of the biological neurons of a human being. So it can create a function that ideally maps the input parameters to the desired output. So as we tend to see something, then we try to understand what is in front of us. We try to have some perception about objects that we see, and the brain helps us, and brain is involved in understanding something visually, understanding something in the audio form, or suppose when someone talks, we are able to interpret that, and when there is a heat around us, we are able to feel it through the senses. So all these things happen around us only with the support of the brain, and all of us must be knowing there is a very well built and very complicated and a very perfect kind of neural network which is designed and developed by the Almighty, which drives the intelligence of each and every human being. So this is going to form the foundation for the development of artificial neural network. So this diagram, I mean, this slide will make us understand or to compare between the biological neural network and the artificial neural network. So all of us had learned about the basics of this biological neural network. In our school days, in our college days, we have learned this dendrites, then axons, all those stuff we have learned. So all that we need to understand. Let us not get into the biological aspects of uh, human neural network. So all that we need to understand now, our eyes, our ears, skin, etc. act like input devices or the input component which try to get some information. That information is spontaneously, right, automatically getting transmitted to the brain, And the brain has got its own mechanism to understand, interpret, and then transmit the information back to us so that we are able to recognize a person. Sometimes we are not able to recognize a person. And when someone talks in a language that we are conversant with, we are able to understand. When someone talks in a language that we are not familiar with, we are not able to understand. So everything happens. So since our birth, as we grow, we collect a lot of knowledge, we get a lot of information through the process of formal learning, informal learning, out of which our brain has got a knowledge base. So this knowledge base is effectively being tapped, utilized, depending upon the sensitivity and activeness of the brain as well as our neurons. And accordingly, our intelligence is being exhibited in decision making, in problem solving, in recognizing, in conversation, in all those. Now, let us forget about this biological neural network and let us turn our attention towards neural network. So coming to this, as we have the input units, as we have a processing unit, as we have the outcome as such in the form of information, understanding, and its kind. So as we look into the structure of a neural network, the first column that you see with all bubbles, right? So this is the input layer, and you go to the last one with a single bubble. This is the output layer, and in between the input layer and output layer, we can have any number of layers, and we call them as hidden layers. So the depth of the hidden layer decides whether a network is to be called as a simple neural network or a deep neural network. So as the depth increases, a neural network gets transformed into a deep learning neural network. So to brush up on the basics of neural network, let us take this as a neuron. So now there is a neuron, right? A neuron takes inputs and it does some computation with them and then produces an output. So here, let us imagine there is one neuron. For this neuron, we have given two inputs. Let us call those inputs as x1 and x2. You can see here x1, x2. So we have taken those values and there is some computation that goes around. Let us not worry about what kind of computation is going across. So some computation takes place that is represented by means of this oval shape. Let us assume some process is going on within this shape, and out of this you get something. Let us call it as the output. So three things happen within this. So what are those three things? The first one is whatever be the input that you give. Here we have got two inputs. These two inputs are going to get multiplied by the respective weights. So we are going to assign some weightage for these inputs depending upon their preferences or depending upon their importance, depending upon the kind of weightage that we assign to the input parameters. So we call the respective weights as W1 and W2. So we have got two inputs x1, x2, and we have got two respective weights W1, W2. So they are being multiplied respectively. So this multiplication takes place. This is the first step that takes place, as we call the process of computation. Secondly, all these weighted inputs are going to get added together. In addition to that, another new terminology is introduced in the process of computation. We call that term as bias, which is represented by the term B. Fine. So in the first step, we have got two multiplications, x1 into w1, x2 into w2. Now, these two multiplied terms will be added up together. So here we have x1 into w1 plus x2 into w2 and then plus w. Fine. So now we add them together. So you're going to have some value now. So as we sum them up, we get some value. This is the second step. Finally, the sum is passed through an activation function that turns an unbounded input into an output that has a predictable form. So now when we do this kind of computation, we may be left with some data, some computed value, which may not help us to arrive at the output in an easier way. Or else the output, the intermediate results that we get out of the second computation may not be in the form which can be directly used for producing the output. So in such cases, we have to go for the third computation to resolve the problem of having the numerical figures which are not predictable. We must be able to go for the third computation, that is called as activation function. So what is the purpose of this activation function? The results of the second computation are going to get supplied to this activation function, and then it is going to work on certain principle, and this function will give us the output. That output is called as y. So now we can map the diagram with all these notational representations. You have two inputs, x1, x2. These x1 and x2 inputs are being multiplied with the weighing factors w1 and w2, the first step. Then whatever that we did with the inputs and the respective weights, the multiplicated terms are being taken, and then we find the sum of these products. Along with that, we add an additional terminology, say b. After that, we take an activation function. This data is fed into the activation function that gives us y. So now you can see here, this y is the output. So hope you understand what exactly happens in a neural network. So NN can be used to solve a problem related to, it can be a tabulated data, it can be a numerical data, or it can be a collection of images, or it can be, say, text document. So neural network can be used to handle whether it is numerical data or images or video, or it can be even text data. So this neural network is capable of learning any kind of nonlinear function, and that because it is able to give us the best solution, right? To the process of approximation, we call this as universal function approximators, right? This nonlinear functions are otherwise called as universal function approximators. So as you know, this network will be able to learn weights, and then it may be able to do the computation and map all the inputs into the respective outputs. So one of the main reasons behind this universal approximation is why do we have to go for this activation function is we have to convert the intermediate data of the computation, which is of the form which cannot be interpreted directly or which cannot be used for producing the output. So activation functions introduce nonlinear properties to the network. This helps the network to learn any kind of complex relationship between the set of inputs that we have given as input parameters and the output to be produced. So now we have to understand there exists a non-linear relationship between the set of inputs that we are talking about and it may be a single input, but later on, as you understand about these networks are capable of producing more than one output as well. So it is able to understand the complicated relationship between the input parameters and the output parameter. So this is possible with the support of the activation function. So thus the output of each neuron is the activation of weighted sum of inputs, right? So to the activation function, we give the intermediate computed sum and the bias, and that serves as the input for the activation function. So that activation function is going to produce the output. So here you'll be able to understand. So the three inputs, the respective weights are being given. Then second one speaks about summing up of the terms that we multiplied along with the bias. They are being summed up. The third one is activation. So hope it's clear to you all what is meant by a neural network, what happens internally, and how the inputs are being taken, how weights are being assigned, then multiplication takes place, then summation takes place, The summed up values will be passed on to the activation function. Activation function will convert the intermediate results into a format which is easy for producing the output, or which is easy to predict the output. So what are the capabilities of neural network? We'll continue further. So what happens if there is no activation function? So suppose if you miss out this activation function, what will happen? So the network only learn the linear functions, and it can never learn the nonlinear relationship between input parameters and the output parameter. So we have to understand activation function is the one which brings in the capability of understanding the nonlinearity between the input parameters and the output parameters in a neural network. So an activation function is a powerhouse of neural networks. So this is the one which adds value to the entire process of computation using neural network. Okay, so now let us focus our attention towards this activation functions. I'll just throw light on this activation functions, because as we try to solve a problem using neural network, we must be able to distinguish between what are the capabilities of the activation functions available, which activation function am I supposed to choose depending upon the nature of my problem to be solved. So it is used to determine the output of neural network, like yes or no, true or false. It may be disease is present or disease is absent, it is positive or negative, things like that. So 0 or 1 and so on. So it maps the resulting values between 0 and 1. Whatever with the intermediate value that you get out of the second step, then the activation function will be able to map it between 0 and 1. In some cases, it may be between -1 and +1 and the like. So it depends upon the nature of the activation function that we select. So the most popular type of nonlinear activation functions are, the primary three types are sigmoid, or we call it as logistic. The second one is tanh. This is hyperbolic tangent. The third one is ReLU, which stands for rectified linear units. So in addition to these three, we will be discussing two more later, but these are the three main activation functions we normally use. So what happens? Let us go through this workflow and try to understand the purpose of the activation function. So here, take input and multiply by the neuron's weight. You know what is input and what are the respective weights and how they are being multiplied. So inputs are taken, weights are taken, they are correspondingly multiplied, and then we have to add the bias. So this value is going to get fed into the activation function. So feed the result of this into the activation function. So whatever you have after adding bias can be called as Ex. Now you apply that X to a function, that is f of x. Now it will be able to map the values between the range of the input, range of the output, between 0 and 1, or between -1 and +1. So what happens here in the last step? Take the outputs and transmit to the next layer of the neuron. So now it is going to get transmitted to the next layer for subsequent processing and usage. So I do believe now, so far, we just started with the introduction about artificial intelligence. What is artificial intelligence? Uh, the birth of artificial intelligence, and what were the milestones in artificial intelligence? Like what were the milestones? What were the breakthroughs the world was able to witness from the year 1950 till 2011, 2014, and so on? And then we were able to understand the difference between artificial intelligence, machine learning, and deep learning. So artificial intelligence was the basis from which machine learning was developed, then deep learning was evolved. And then we moved into the difference between biological neurons and artificial neural network. Then we just learned about the basics of neural network, what is meant by a neural network. Then the working principle of neural network is being explained. And I told you there are three major steps involved. And then I also explained to you what is the purpose of an activation function. So the main purpose of activation function is to make the system to understand the non-linear relationship between the input parameters and the output parameters. Right? So whereas the function can only, the neural network can understand only the linear function, The activation function is the one which makes the neural network to understand the principle of non-linearity between the input parameters and the output parameter. Well, so for want of time, I'll just explain the important points about this activation function. So this is the sigmoid or logistic activation function. So from here we can understand this is a kind of S curve, right? So it is being called as a sigmoid function. So the formula is being given. So what happens here? So whatever with the data that you give, whatever with the data that has been passed on to the activation function, sigmoid activation function, so it is able to map the values between 0 and 1. You can see here in the y-axis. So we have 0 and 1. It is able to map all the input values given in the x-axis, that is in the bottom. They are being mapped correspondingly to the respective values of zeros and 1. So we can call this as a smooth gradient, like the transition is very smooth as we look into the pattern of the curve, as we look into the shape of this curve, it is very smooth. So this prevents jumps in the output values. It is not, there is no hop in the output value. There is a kind of smooth transition from input to the output. So we can understand there is a smooth transition wherein we cannot see any jumps of output values. Then output values are bound between 0 and 1. We understand very much because here the minimum value is 0 and maximum value is 1. The boundaries are 0 and 1. Between 0 and 1, normalizing normalizing the output of each and every neuron, because each and every neuron is going to give some value. Then it gives us clear prediction for x, right? X value, that is here it is represented as z, but anyway, you can take the bottom one as x-axis. So when it is above 2 or below -2, right? So it tends to bring the y value to the edge of the curve very close to 0 and 1. So as you could see here, so if it is -2, like here in the bottom line, -2, then most of its value are tend towards 0. Likewise, if it is 2, if the input is 2, then 2 and beyond, all the values are almost equal to 1. So this enables very clear prediction. We are able to make whether the values are 0 and 1, right? I mean, 0 means false and yes means true, or 0 means no, yes means 1. So we are able to make out this kind of prediction. So then what is the disadvantage of this activation function? So here we call this as a vanishing gradient. So here, as you see here at the bottom, right? And for most of the values, I mean anything less than -2, like most of them are being taken as 0. So we're not able to distinguish between the output values and output values you get for different input values. For different input values, you get at most, I mean, on most of the occasions, the 0. Likewise, as you see here, for 1 also, for all the values beyond 2, they are being mapped to 1. So we are not able to, so the distinction between the outputs against the respective input values. So this, what is the disadvantage for very high or very low values of x, as you say? I mean, anything between -2 and 2, it is able to show very good transition and prediction. But the values beyond that, beyond the range of -2 and +2, we call them as for very high or very low values of x. There is almost no change in the prediction, causing a vanishing gradient problem. Here, as you could see here, so this is the point that we call as vanishing gradient, and this is the point that we could, because there is no gradient, right? It has got flattened. So we call that as vanishing gradient. So prediction using a vanishing gradient problem. So this can, what is the inference that we get out of this? Suppose if the vanishing gradient happens to be very large, right? So that will make us understand the network, either of the two aspects. Number one, so the model refuses to learn from the data that we have given any further. It has reached the saturation state of its learning, or else it may be too slow to reach the accurate prediction. It is going to take a lot of time. The process is very slow to converge to the solution. So then the other disadvantages are the outputs are not zero centered. Like the outputs are not zero centered. Now it varies between 0 and -1. Then it is computationally expensive. The process of computation is very complicated. So naturally, it is computationally complex. The second one is tan H or hyperbolic tangent. So because we have already discussed about this sigmoid, you'll be able to correlate that with this. So now there is a difference now. Now it crosses through zero. So now this is zero centered, whereas sigmoid was not zero centered. So now it is able to have zero here, that is in the middle, making it easier to model inputs that have strong negative, neutral, and strongly positive values. So when the data set happens to have strong negative, strong positive, as well as neutral values, then this tan H will be able to give us better solution through the activation process. So disadvantages this also has vanishing gradient, as we could see here. That there is a flattened line here at the bottom as well as at the top. So this also has the vanishing gradient, and the gradient vanishes at certain point, right? So here also for a very high and very low values of x, there is almost no change to the prediction. So that causes vanishing gradient problem. So what is the reason for this? As we discussed earlier, either the model refuses to learn or the model is taking longer time to predict the accurate value. And here there is no problem of this no zero crossing, it is there. But anyway, this is also computationally expensive. Then the next one is ReLU. This is the one which is very frequently used nowadays by the researcher and those who are working currently on machine learning and deep learning. So here you can see this pattern is quite different, and this is computationally efficient because it allows the network to converge very quickly. Like as we apply this, it is able to make the model to converge to the solution very faster. And then this is an illustration for nonlinear. This doesn't show the linear property. This also shows the nonlinear property. So although this looks like a linear function, like this looks like fitting a line. Though it looks like a linear function, ReLU has a derivative function and it allows for back propagation. I'll let you know what is meant by back propagation in the next slide. So the disadvantage, the dying ReLU problem, as we had that vanishing gradient. When the input approaches zero, or when the inputs are negative, the gradient of the function becomes zero. You can see here, right? So when the input happens to be negative, or as long as the inputs are negative, as long as the input is a zero, then you get the result as zero, becomes zero. The network cannot perform back propagation, and it cannot learn any further. Now here we have to go for back propagation because these values happen to be zero. We cannot go for the subsequent iterations. So how best this problem can be solved? So now we are going to go for a modification or a variant of this ReLU that we call as leaky ReLU. So this leaky ReLU is going to provide solution for previous example that we saw here. We are not able to do any kind of back propagation because all the values tend to be zero. So, but here they are not zero and they are giving some other value. So, what is the advantage of this? It prevents dying ReLU problem. What is dying ReLU problem? Suppose if this gets extended, here this is the point where it is zero. Suppose if this gets extended further, then most of the values will become zero when you want to go for the next iteration in the neural network computation. When all the values become zero, probably we will not get any substantial results. So for that purpose, we want to address this problem of a dying ReLU. So this variation of ReLU has a small positive slope in the negative area. There is a small slope here in the negative area. So it does enable, this is able to help the network to go for back propagation even for negative input values, unlike ReLU, right? This varies from ReLU in this aspect. So this is unlike ReLU, it is able to get values which are non-zeros. So the disadvantage, results are not consistent, and leaky ReLU does not provide consistent predictions for negative input values. Though this is giving a solution for handling the zero values, but however, and there is not an assurance that this works always well and gives the best values time of prediction. So it may be shaky and we have to be careful when we are using this. Then another important activation function as we talk about neural network is softmax. And probably the discussion on activation function would be incomplete if we don't touch upon this softmax. So here you can see there is a beautiful transition from bottom to the end. And as we could see here, there are a lot of values given 0.25, 0.5, 0.75, 1.25, 1.5 and the like. Here there are going to be multiple output values here. So it is able to handle multiple classes, only one class in the activation, only one class in the all other activation functions that we have discussed. Hope you will be able to recollect. We discussed about sigmoid, we discussed about tanh, we discussed about ReLU, and we did discuss about leaky ReLU. So this differs from all those previously discussed activation functions because they will be able to handle only one class, either yes or no. But whereas this is able to handle multiple classes, that is, it may be able to produce multiple outputs. So only one class in the previously discussed activation functions. So it normalizes the output for each class between 0 and 1 by dividing their sums giving the probability of input value being in a specific class. For instance, suppose if we develop a model for the classification of say cats, dogs and birds. I am going to have a collection of cats, dogs and birds. Then I am going to train the model for the identification of a cat or a dog or a bird. Then if I am going to test the model with a new picture that I have in my hand, to check whether it is a dog or a cat or a bird, the model will come out with the probability of identifying the object as dog, the probability of identifying that object as cat, and the probability of identifying the given input object as bird. So among the three probabilities it has got, the one which has got the highest probability will be given as the output. So now if the prediction is accurate, then that accuracy will match with the highest probability. If the model is not working well, probably we get wrong results. So it is useful for output neuron, and typically sigmoid is used, softmax is used only for the output layer for neural network that needs to classify input into multiple categories. So when you want to go for multi-class, when you want to go for multiple outputs, multiple classification, then this is the ultimate solution for us. So we have to use only that. So then, what are the challenges in neural network? So while solving an image classification problem using neural network, the first step that we have to do is to convert the two-dimensional image into a single-dimensional data set. We call that as a vector, right? So say, one-dimensional vector or, vector is a unidimensional data set. So that is going to be used for training the model. So what do you understand from this? If we are having a set of data, we call them as image data set, and we know we normally work with two-dimensional data set. We work with two-dimensional image set. So when you want to make the model to understand this, we cannot make the model to understand any image or any data that you give in the form of image directly in the two-dimensional form. Rather, we have to convert it into a vector, one-dimensional vector. Only then you can arrange them as inputs for the neural network. Hope you are able to understand. So, or else, even as we progress further, you will be able to, understand what I mean by this. So, the number of trainable parameters increases drastically with the increase in the size of the image. So what do you mean by this? So if I have a dog image, which is represented as a matrix of 10 cross 10, for instance. So we understand 10 into 10, we are going to have 100 information. Each cell will represent one intensity of the dog or one pixel of the dog. So 100. So if I have an image of size 100 cross 100, it is fine. And suppose if I have an image which is bigger than that. So we can imagine each pixel is going to serve as the input. So then there are going to be multiple inputs. Even if I have an image of size 10 cross 10, that will make me to have a neural network with 100 inputs, right? So when the image size increases naturally, the input that I have to give to the neural network also increases, leading to a lot of complications. So that is the reason why when we talk about this neural network, we have to learn how this dimensionality reduction can be done with the support of convolutional neural network that we will discuss shortly. So then here we have to understand artificial neural network doesn't bother about the spatial features of an image. And please, those who are not familiar with digital image processing, don't bother much. You just understand spatial features as the pixels of the image. Pixels of the image, right? So ANN ignores the pixels details of the image. Rather, it takes only the important spatial aspect. I mean, important spatial features of the image, right? And probably how the eye looks like, how the nose looks like, how the ear looks like, how the texture looks like. So these kind of features are being extracted. So that is going, those kind of color, feature, texture, size, shape, all these inputs are being extracted from the given image and they will serve as the input for the neural network, not the image directly. Hope you understand. See here, there's a small, I mean, dog images here, right? So if we try to understand the size of this dog, it may be say 100, 200 pixels. But here, as you see here, it is not 200 pixels. It is only very small network. So from the image, we try to extract the essential features. Using those essential features, we try to construct the neural network instead of taking all the pixels of the image. Hope it is clear to you all. So now let us continue. So another common problem in all this neural network is the vanishing and exploding gradient. We have discussed about this vanishing gradient and exploding gradient when we discussed about sigmoid function, when we discussed about tanh, then ReLU and leaky ReLU. Okay, so this problem is associated with back propagation. Suppose if there is a vanishing gradient, if there is an exploding gradient, what is the disadvantage of this vanishing gradient? The most important disadvantage is we may not be able to continue with back propagation. So what is meant by back propagation? From the diagram, you will be able to understand. So we have inputs to the network. We call this as input layer. Then in the middle, you have the hidden layer. And if it works well, if everything is perfect, then we go for feed forward. And using the activation function, the data will get converted into the output. But suppose if we are not getting good result, if you're not able to continue because of the problem of vanishing gradient or exploding gradient, which is a problem, then we have to go for back propagation where we have to go back and we need to adjust the weights. Okay, we have to adjust the weights. So this process is called as back propagation. If you're able to move forward, it is feed forward. When you go back and try to adjust the weights of the input, this is called as back propagation. So this back propagation is the issue which has to be addressed, right, when you want to tune the model. But if there is a problem of vanishing or exploding gradient, then this becomes impracticable. We may not be able to do this back propagation effectively. So the weights of the neural networks are updated through back propagation by finding the gradients, right? So we have to rework on it. So now from this, you'll be able to understand what are the advantages of this convolutional neural network. So here the CNN learns automatically without being explicitly programmed, right? So hope you'll be able to see this, how it works. I think we must be able to go for a slideshow presentation on this. So that will be able to, once again, let me try this. Yeah. So now you can see. See, from the input image, features are being extracted. They are fed into the different layers, and then the output layer produces the result, whether it is cat or not. Okay. So CNN learns that we are going to use filters. Please hold on your doubts about the filters. We are going to use a terminology called filter. So it is going to apply the filters automatically, right, without being mentioned explicitly. I mean, I'll let you know what is meant by filter, how they are being used in the convolutional neural network. So these filters help in extracting the right and relevant features from the input data. So here you have to understand what is meant by the relevant correct features. Now, as you see between the dog and a cat, there are differences with respect to its eye, its ears, then its shape of the face, and all those stuff. This is what we feel like, this is what we refer as features. So, the CNN convolutional neural network must be able to extract the features. I will let you know how they are being done shortly. So, this overcomes the curse of dimensionality. Suppose if you have a very big image, if you have a very high resolution image, then the number of pixels will be more. So in such cases, the convolutional neural network will help us to reduce the size, and then we may be able to handle the data effectively and efficiently so that the computation becomes simpler and easier. So that's an illustration with Rahul Dravid, and suppose if you develop a model for the recognition of sports persons by giving their image, it must be able to give the name of each and every sports person. Then it must be able. We have to train the model with all those pictures of sports persons. Then it will try to identify what are the features of Rahul Dravid, and his nose features, his eye features, ears, and the like, and then it will use these features to recognize and when his photograph is given at the later point of time. Some other photograph of Rahul Dravid, not necessarily this. So CNN captures the spatial features from an image. So spatial features refer to the arrangement of pixels and the relationship between them in an image, right? So spatial features refers to arrangement of pixels. I told you, right? So it is any image is a collection of pixels, or it is a comprehensive representation of pixels. So then there will be a relationship between the pixels in a particular image. So we are going to make use of, we are going to explore the relationship between these pixels, and then the features will be extracted. So this may help us in identifying the object accurately. Then the location of the object can be identified. Then what is the relation between the target object and other objects in the image? And a lot of wonders can be done with the support of neural network. So here we can see we are going to apply a filter, or we call that as kernel, and that is going to help us to process the pixels of a given image, right? Um, in the way that it is shown here. It is going to be processed from left to right and from top to bottom. We start from the left top corner, then the process has to be continued till the filter reaches the bottom right corner, and the one on top is being called as filter, and the one at the bottom can be taken as the input image. So the input image is being processed with the support of this filter, or we call this as kernel. So a single filter is applied across the different parts of the input to produce the feature map. See, we can see here. So we can see here from different positions we are able to select the features. So as you see here, from this particular 3 cross 3, one feature is being extracted. Then from the second part, another feature is being extracted. From the third part, yet another feature is being taken. It continues like this. So hope you're able to understand. We have a filter, right, which sits on top of the image, and then that is applied over the entire image, and then we are able to extract specific features from each portion of the image as it is shown by the shaded region, and so it is able to help us to extract the features across. So hope it is clear to everyone, right? I'll get into the aspects of application of filters on the image. So before that, I will just give a comparison between artificial neural network and convolutional neural network. So what are the properties with which we are going to explain? The properties are data, then parameter sharing, spatial relationship, then regarding this vanishing and exploding gradient, what are the learning patterns and the like, right? So we have got the two classes, neural network and convolutional neural network. So this neural network exclusively works on tabular data, and this convolutional neural networks works ideally good on image data. Then parameter sharing is not possible with neural network, whereas it is possible with convolutional neural network. Spatial relationship, there is no spatial relationship among the tabular data, so it is not possible. But when you take an image, it is possible to have a spatial relationship, so it is yes for CNN. Then regarding this vanishing and exploding gradient, this is associated with the process of problem solving or the behavior of the neural network. So this is applicable for both neural network as well as convolutional neural network. Then about the learning pattern, how does it learn? In the case of neural network, it should be done manually, but whereas in the case of convolutional neural network, it happens automatically. So from this small video, you will be able to understand what happens. Suppose if we have a collection of images, then probably we may be able to extract as many features as possible from the given input image. So to illustrate, we have taken texture, color, shape, and size. Okay, so if it is pineapple, it will be able to take the texture, the color, the shape, and then size. If it is apple, it will accordingly take. If it is orange, accordingly, the features will be extracted. So this is how the model works. This is how the CNN convolutional neural network model works across different applications and different domains. So hope it is clear to you up to this point. So now let me continue. So this is about the how our brain functions and which area is responsible for what. Which area is responsible for the vision and which area is responsible for different activities that are associated with the visual perception. Because visual perception is the one which makes a person to understand an object in front of him or her. So I let me not spend much time on this because you know what is perception, and you know the visual perception is mimicked uh, through the CNN convolutional neural network and deep learning neural network. When we when we develop a model for image recognition, image identification, then image tagging, then image captioning, and many such things. So here, suppose if you give this model to a convolutional neural network, so it may come out with a caption saying that a happy boy is standing on the chair, like, because it is able to see the various features of the entire image, and then it will come to a conclusion. Say because conclusion that a boy is standing on the chair. So this is the reason why, like, when we form perceptions about things that are around us or persons who are around us, it is basically like anchored on our understanding about the surrounding or our experiences about the surrounding or our past experiences, whether it is good or bad about the surrounding. So all those things will play a very very strong role on the perception of anything around us. So the same thing happens with the CNN also. So depending upon the perception it gets from the image, accordingly the classification or prediction takes place. So this is about the CNN. We are into the CNN now. So if you understand the basics of CNN, probably in the tomorrow session, we will be able to proceed with, excuse me, we will be able to proceed with the working of, I mean, convolutional neural network in detail, which in turn will help us to understand deep networks. So you just have a look at this slide. So this is the typical illustration of a convolutional neural network, we shortly call as CNN. So we have an input. So from the input, let us take this to be a car. So from the car, we have to extract the features. We want to identify whether it is a car or a bicycle or a motorcycle or any other vehicle. So now it must be able to extract the features, like what is the size, and then what is its height, what are the features in the object, where the lights are, where the wheels are, all these things are being extracted. This is what we call as feature extraction or feature learning. So this process takes place by the process of convolution, right? You can see here at the bottom, we have got the labels here. This is the input. Then the convolution operation takes place. This convolution takes with respect to the input image. After this convolution, as you all know, we have to necessarily apply activation function. We call this ReLU, right? This activation function is being used. So this activation function will help us, as you know, to transform the given input values into the respective transformable or understandable predictable values. This is followed by another process called pooling. Please reserve your observation about this pooling. We will discuss about it a little later. So from here, we have to extract further information, and this convolution operation can be repeated any number of times until we decide that the quantity of feature or the dimension of feature that we extracted is sufficient, right? So as you see here, after pooling, suppose if we start with the first level of convolution, say here, suppose if I stop here, then the feature that I get will be bigger when I compare to the feature that I get here. So as we progress towards right, then the feature size will get decreased in the sense that the feature will get refined further. So what is the advantage of refining the features? So as we refine the features, then the number of input are going to be lesser. So when the number of inputs are lesser, then the complexity of the neural network will also get reduced, right? So here we have the convolution, we have the activation, then we go for pooling, then convolution, ReLU, pooling. If this process goes like this, so at the end, this is the feature extracted from the input image, and later we go for the construction of this neural network, right? We supply the data. This is one dimensional vector of the features. Then we can go for, I mean, you have to understand this to be a neural network, as simple as that. There may be connections between these inputs, and activation takes place. Then the activated, the output of the activation function will get transformed into the output value. We may be able to classify whether the given image is a car or a truck or a van or a bicycle, as you understand. Here, one point I want to insist upon. Now, whatever we extract out of this process is being called as convolved feature, or we call this as activation map, or we call this as feature map, right? So the output of this entire process is being called as convolved features, activation map, or feature map. So here, I will just explain to you the CNN layers. Suppose if you imagine this is an input image with all zeros and one. Let us imagine this is a binary image. So we take this 3 cross 3. Out of this 3 cross 3, we do a kind of convolution operation that will fetch us one data here. That will fetch us one data here. And then I am going to have another 3 cross 3 that will fetch me one data here. So if I have one input image and one filter, that is one convolution operation, that will fetch me one set of data. That is, as you see, the first rectangle here. If I am going to use multiple filters or multiple convolution operation or multiple kernels, then that will give me multiple features as it is shown here. So this is one set of features. This is second feature set, third feature set, fourth feature set. So here we have to understand. So this is got out of one filter. This is got out of the second filter. This is got out of the third filter. Of course, the input image is the same. So please note this down. The selection of number of kernel or filter determines the number of feature map or activation output being produced by the convolution layer, right? So if there are 10 filters, there will be 10 feature maps. If there are 5 filters, there will be 5 feature maps. Okay. So what happens, internally in the convolutional neural network? The first operation is convolution operation. The second one is calling for the activation function. Third one is pooling. Then features are extracted. It is being passed on to fully connected layer. So as we discuss about convolution, we should understand what is meant by striding, what is padding. We have already learned about ReLU layer. And then there are different types of pooling, min pooling, max pooling, average pooling, etc. So let us illustrate on max and min pooling. You know what is fully connected layer. We will explain later. So here, let us take this example. If you understand this, then it is very easy for you to correlate your understanding on the functionalities of or the functioning of a convolutional neural network. So this slide explains the convolution operation, and you can just have a look at what is given here. Can you see what is given here? There are two components in the first row. One is the input row, I mean input, the second one is kernel. So now this kernel is the one which is going to be used for multiplication. We are going to use this kernel for feature extraction from the input image. Now, for instance, if we take the input image, now let us assume each one to represent a pixel. Each one, this A, B, C, D, E, F, G, H, I, J, K, L. So each one represents a pixel. So I have taken a 2 cross 2 sub image, that is a portion of an image is called sub image. So then I'm going to go for multiplication with this kernel. So as I take this kernel to be multiplied with this input image, so it is 1 to 1. So A multiplied with W, B multiplied with X, then C multiplied with Y, and F multiplied with Z. You know how this multiplication takes place. We have already seen in the previous slides. That is the multiplication with X1 into W1, X2 into W1, and so on. Okay, so now we have got this. Then secondly, we have to move this to the next one. Like we have to do the sliding. So then it is C W D X G Y and then H Z. So you get this. Okay, you get the next one. Suppose if you want to go for, there are two types of moving the kernel over the image. One is called as overlapping pattern. Second one is non-overlapping pattern. If I am going to slide this image, right, by one step. So what will happen? I will place this kernel on B, C, F and G. Hope you understand. At present, the kernel is on A, B, E, F. So if I move it one step, then it will be on B, C, F, G. So when I go for the multiplication, it is B, W, C, X, F, Y, and then G, Z. So again, I'm going to move it one step. Now it will be on C, D, G, H. That will give us this. So I'm going to move the slide down by one step. So now the kernel will be on this E, F, I, J. Then next it will be on F, G, J, K. Again, it will be on G, H, K, I. So accordingly, you get totally 6 units. 1, 2, 3, 4, 5, 6 for 6 different multiplications. So hope you understand this. So let me explain the same thing with this illustration. So consider an input image of size 5 cross 5 and a filter of size 3 cross 3. Then the output image size will be like this. So here I have the input image. So this is the kernel. One given in the brown line is the kernel. So the sub image that is going to be multiplied with the kernel. So here I have got the filter. So this filter can also be referred as kernel. This can be called as a mask or it can call it as a filter. So as you look down, you can see how the multiplication takes place. This one is being multiplied with 0, 2 with a 0, and then 1 with 0. You can imagine like this. Suppose if you superimpose this filter on this, right? So this 0 matches with the 1, this 0 matches with this 0, and this 0 matches with -1. So we just multiply them and add together. That will give the result as 0. So now we have got this 0. Okay. Input image, filter. This is multiplication operation. Output image. We all know the output image is the feature map. Fine. So now let us see what happens in the next step. I am just moving it by one step. So I work on the sub image that gives me 1. Then I work on the third one that gives me 1 again. Then I move down the filter by one row that gives me 1, and we go like this. So now there should be a kind of an estimate to know what will be my feature map size or what will be the size of my output image. If I have an image of size, say IH cross IW and the filter size say FH cross FW, where H stands for height and W stands for width, right? So number of rows and columns. So when I have like this, then I can apply this formula. So you know what is IH, you know what is FH, you know what is IW, FW, and you know what is, I mean, here I have given example. This is 5 cross 5, IH is equal to 5, IW is equal to 5. So this is 3 cross 3, FH is equal to 3 and FW is equal to 3. So now you have to apply this IH minus FH plus 1. This will refer to number of rows that you will have in the output image, comma. And this is IW minus FW plus 1. This is number of columns. So what does it mean? Here, as I take, that will give me number of, I mean, the size will be of 3, comma 3. I'm sorry. I get the image of size 3 cross 3, and this is my output. That is, I have an image of size 3 in 3 cross 3 image is being got. So this is what we mean, right? So we can apply the formula and see what will be my output. Well, so now I told you, you have to take into consideration the stride. When you develop a model, the model will ask us what is the size of the stride. So that shows us how many number of rows and columns are you going to skip when you move the slide from one position to another position. So normally by default, stride is equal to 1, S is equal to 1. Suppose if we set S is equal to 2, let us see what happens. See, now we can see previously it was occupying this 3 cross 3. When I give this is equal to 3, it skips 2 columns. So now what happens now? I'm able to get the values for this, right? So here this is a problem. Please take a note of this. So when I give stride is equal to 3, previously it skipped 2, then it was placed here. After the second stride, after the second operation, it again skips 2 and then now it is here. But now I have only one column. The rows are missing. It is one column and 3 rows. Whereas to perform the operation, I need 3 cross 3. So this is a problem which we encounter. Let us see later how this problem can be solved. Anyway. So then accordingly we get, so from this you can understand, so as the stride is increased, then the size of the output image will be smaller. So hope you are able to understand. In the previous case, it was 3 cross 3, but here it is 2 cross 2. So when you increase the stride, probably then the less number of feature will be extracted. And suppose if the stride is equal to 1, which is default, that will give you more amount of features. So you can calculate the output image size by applying this formula. There is a problem, right? So when we discussed about this is actually a problem. So how this problem can be solved? Here we don't have more number of rows and columns to continue the computation. So in such cases, we can go in for padding. Padding is a solution for an image where you are not able to do the complete operation. So what are we going to do? So now you have to understand the actual image size is only here. So the previous 5 cross 5, we can see here 1, 2, 0. So this is the 5 cross 5 image, the inner 5 cross 5. So now we don't want the output image to be of smaller size, say 3 cross 3 or 2 cross 2. Instead, I want to restore the original size of the input image. In such cases, the solution is going for zero padding. You can see here on the four sides, top, bottom, left, right, we have added zeros. So this is called a zero padding. The boundary contains the boundaries are augmented with padded with zeros. So when do we go for these kind of padding? For two reasons. The first one is when boundary contains some valid information. That is, I cannot skip the valid information in this boundary. In such cases, we can go for zero padding. Or else when the filter is not able to fit with the image completely, as we saw in the earlier case, we were not able to produce 3 cross 3 perfectly. In such cases, we go for zero padding. So we can understand here, this will give us a perfect 5 cross 5. See, the size of the image is same as that of size of the feature map. Okay, So it is almost like we are able to explain here how it happens. Well, so this is again another formula that we have to follow for the computation of size of the output image. So then the next aspect is pooling. So what is meant by pooling? You know, suppose if this is the feature vector, then from the feature vector, I am going to extract the significant values. Out of this, the significant values will signify or will denote the special features of the image, which is sufficient for the model to to recognize an image by using these features extracted. So how this can be done? Pooling layer replaces the output of the network at certain locations by deriving summary statistics. Please try to take a note of this. So you have the feature map. Out of the feature map, we try to extract the most important features from the feature map. So now we have to understand the process. We have taken the input image. From the input image, we did the convolution operation by applying striding, and then by applying the activation function, then we are able to get some values. So these values are to be done with max pooling, min pooling, sum pooling, many kinds of pooling are there. So what is the purpose of this? Pooling layer replaces the output of the network at certain location by deriving summary statistics. Why we call this a summary statistics? I'll let you know. So from here, we can, if you have this 1, 2, 3, suppose if you're going to use a 3 cross 3 filter, right? So then the max pool stride is equal to 1. So what will happen now? I'm going to have this 3 cross 3 being selected by the filter, selected by the convolutional kernel. So what will happen now? Now out of this, we are going to select the max value. So the max value is naturally 2. So then stride is equal to 1. We skip the first column, then it takes the middle one, right? 3 cross 3. So this is, in this, the max is 2. Then the next 3 cross 3, the max is 1. Now you are able to understand. So how do we get it? So here, this illustrates the max pooling output when stride is equal to 1, and this illustrates when stride is equal to 2. So I told you already, when the stride is equal to 1, the feature map will be bigger. When the stride increases, the feature map size decreases. Again, the formula for calculating. So, so we are done with what is meant by convolutional operation, right? Convolution filter we discussed. We discussed about zero padding. What is the purpose of zero padding? How does it help? Then we discussed about what is meant by a stride. So what will be the impact of a stride is equal to 1 and stride is equal to 2, and how to select it. Then we have to learn about this fully connected layer, dense layer. So neuron in this layer have fully connectivity with all neurons in the preceding or succeeding section, as you could see here, right? So you're going to have a collection of neurons. The fully connected one will have a perfect connection with respect to the previous set of layer and the next set of layers. They are connected to each and every data point. So we call them as fully connected. So this is used to map the representation between the input and the output. It has to establish the relationship between the input and the output. So it is followed by which one? This fully connected layer. It's followed by the convolution layer, pooling layer, or even after flattening. Once you convert the 3 cross 3 into a one dimensional. Tomorrow we will be discussing about what is meant by this flattening. How do we flatten the feature map? So that we will discuss tomorrow. So this converts a matrix into a vector. So FC layer is similar to convolution layer, but the difference is it is fully convolved with all neurons in the preceding and succeeding layers. So in the case of convolutional layer, we work with each and every data point along with a filter. Whereas in the case of fully connected layer, we are going to work in tandem with the preceding layer as well as the succeeding layer. So I think it is time to focus on popular convolutional networks. And to quote a few, I have just taken few interesting networks. And you know, this LeNet was the one which was introduced in the year 1990. So this came into existence, and here by looking into this leisurely, you will be able to understand. So how many? This is the input. Then convolution operation takes place. This is convolution one. It is given as C1, right? So like this, they have given how many convolutional layers are being used. And what is the feature map that has been extracted, what is the size of the feature map, everything is being given. So I'll just illustrate the first one. This is the first convolution operation, and you can see here, S stands for stride. Stride is equal to 2. Okay, so here one, you can see the alternate shades, right? So light and dark color. So 1, 2, 3, 4, 5, 6. So we have got the output as 6 different feature maps. The size of them are um, 28 into 28, right? So you have taken the input of size 32 cross 32. Now we have reduced it to 28 into 28, but 28 and 28 into 6, because we have got 6 features. That means, um, how do you get 6 features? How do you get 6 feature maps? I told you earlier that will be only one input image, but you can use multiple filters, right? So this is the output of filter 1, this is the output of filter 2, this is the output of filter 3, this is the output of filter 4, filter 5, and filter 6. So you get 6. Okay, so then we go for again sampling, then this process continues, right? So wherever you have yes, you have to understand yes stands for stride, and this 14 cross 14, then 28 cross 28 refers to the feature map size, and then what else is available. So then they have given how many layers are there, C1, C2, C5, and so on. So here we convert it into correspondingly unidimensional or a vector, and then we go for computation, and the last one is the output, right? Full connection they have shown. So you will be able to understand what is meant by fully connected from this diagram. So the next one is AlexNet. This was popularized convolutional neural network, right? And in 2012, there was a big challenge about this ImageNet, ILSVRC, right? This was a kind of competition which was meant for ImageNet large scale vision recognition competition, right? And they frequently conduct competition to come out with refined, renovated, optimized models for image recognition. So this challenge, this was AlexNet outperformed the state of art networks which were there. In the year 2012, AlexNet was able to outperform all the previously reported ones. Hello. இன்னொரு ஒரு 4 ஸ்லைட் இருக்குமா, முடிய போகுது. ஓகே ஓகே. So this is the one like which was able to like uh, make the world understand image processing is made simple with CNN with the support of AlexNet. Then ImageNet, as I told you, ImageNet large scale visual recognition challenges a competition. So samples were selected enormously, and the challenge involved a collection of 1.2 million images were collected, right? And they had to be classified into 100 different categories. Like this is the challenge which was put forth by uh, ILSVRC, right? There will be about 1.2 million images. They are to be accurately classified into 1,000 categories like birds, dogs, people, cars, geometric shapes, and the like. So in the competition, right, this Google Net was able to win the competition in 2014. So Google Net, as you know, it was developed by Google. Then it used average pooling instead of fully connected layer. So we can do some modification in the model by incorporating optimal changes, right? They must be able to give us better solution. So uses average pooling instead of fully connected layer. So this won the game in the year 2014. Then this VGG net was the runner-up, right? Following this Google net in the same year. So it showed the depth of the network as the key to perform. They increased the depth of the network. They had more number of hidden layers, and they were able to show the better performance. So then they used a 16 convolutional fully connected layer, right? And extremely, it was a kind of homogeneous architecture. So it used 3.3 convolution, and the pooling size was 2 cross 2. But because it was very small size filter, and the pooling size was also very small. It had to involve a lot of computation. So the computation was expensive, and so it required large amount of memory. That was the overhead of using this VGG net. Then the next one is ResNet. This is like a winner in the year 2015. This was able to win the competition in the year 2015. So it was able to this is from Microsoft. Then it was able to win over all the contemporary models. Then this was implemented originally with 152 layers. You can imagine the hidden layer, the size of the depth of the network was 152. So then it introduces the concept of residual learning. This is a new learning process. As we talk about learning, the model is able to learn and then proceed. So I think this marks the end of this presentation, and it happened to be a very lengthy because if we don't cover up all these things, probably tomorrow I may not be able to focus on working on convolutional neural network. So I stretched the time beyond the schedule, and hope you don't mind. And thanks for being with me. I thank the organizers and I thank the participants for your patience and for being with me all through. So let us meet tomorrow in the session 2. We will discuss more about the working of convolutional neural network. This marks the end of it. And if you have any questions and questions to be clarified, you can just post it across, and the questions will be answered shortly. So thank you. Bye for now. This marks the end of the session. Thank you, everyone. See you tomorrow.